Hi, I'm Sal Gandhi. With Anish and Samanyu, we built the Subfab Drain Sentry, a low-cost system to help fabs reclaim ultra-pure water by identifying in real time which water can go straight back into the process. Fabs use many water lines, yet small rinse streams aren't monitored at the tool level. As a result, water that could be reused often goes through expensive treatment just to meet strict purity standards. Without smart routing, water and energy are wasted. So we built the three-tier system using TDS and temperature sensors. Blue means direct ultra-pure water reuse, green means moderate filtration for utility use, and green means discard or brine management. One note though, our prototype uses simplified sensors, but the same logic can scale to industrial setups. The Sentry runs on a Raspberry Pi Pico for detecting TDS changes. AC-driven sensors prevent polarization, keeping readings stable. This low-cost prototype demonstrates point-of-use classifications, even if industrial precision requires advanced sensors.
There are two parts to this algorithm, the math and the logic. First off, we have to compensate for temperature since hot water reads artificially high TDS values. So the first equation normalizes to 25 degrees Celsius. Afterwards, we can convert voltage to parts per million using the formula that DF Robot has given us. Once we have done that, we can use the TDS value to result in three possible actionable situations. The first one being blue, we can reuse the water; green, we can reuse with filtering; and red, the water must be discarded. And these values aren't just made up. They come directly from semiconductor fabs. Companies like Intel or Taiwan Semiconductor use values similar to these.
Now, the innovation of real-world impact, we want to be able to account for the temperature, so TDS readings are automatically adjusted lower. And these three-tier routing logic, that means that for every process in the system, we want to flow into different treatment streams to make them accurately treated and not over-treated. And we want to do this kind of all $100 that we were given. But we also have something that we'd like to improve on. We want to be able to make a small scale replica of how they are pumped out into different streams. We want to add pH so we get more accurate TDS readings. And we want to have hundreds of these little sensors all throughout these pipes, and to make sure that we can track trends to detect early leaks and make sure that a small problem doesn't become a big problem. We also want to make sure that everything is completely accurate, completely correct to all the SEMI F63 UPW standards, and we want to make sure that everything was done with all these small little tools to make it cheaper for everybody.
We hit many failures, but the three biggest were a voltage mismatch, a broken library, and an incorrect pin. Every time, we discovered what didn't work, and we aimed to build something better. Sometimes, even going through hours of trial and error. Thank you for watching our presentation.